Hello students, in our last class we dealt with the concept of empirical formula and molecular formula. So what is empirical formula? Empirical formula represents the simplest whole number ratio of various atoms present in a compound, whereas molecular formula shows the exact number of different atoms present in a molecule of a compound. So students, empirical formula represents the simplest whole number ratio of various atoms present in a compound. Molecular formula shows the exact number of different types of atoms present in a compound. So formula of hydrogen peroxide, as you all know, that is H2O2. When we take the common factor, that is the 2, which then the empirical formula will be HO. So as you all know, the formula of glucose is C6H12O6. So here the common factor is 6. So the formula will be, now the empirical formula will be CH2O. So this is the empirical formula. Okay, so now what is the relationship between this both? So students, from both molecular formula and empirical formula, molecular formula is equal to N into empirical formula. That means we can say that molecular formula of H2O2 is twice that of empirical formula. So molecular formula of C6H12O6, that is glucose, is 6 times that of empirical formula. So students, let us see a question from our NCERT textbook, question number 3. Determine the empirical formula of oxides of iron which has 69% of iron and 30.15% of oxygen by mass. So first of all, let us make a table for solving this question. So first, in that we have to write the element, then mass percent, what is given, that is given in the question. So the element is iron and oxygen. So iron is, the symbol is Fe, and oxygen. Okay, the mass percent is 69.9%, and here also that is 30.15%. So it is convenient to make this percentage, mass percent, into that 100 grams of compound. So when we can write it as 69.9 grams in, that is in 100 grams of compound, its the composition is 69.9 grams, whereas here 30.15 grams. Okay, so now next is the moles. As you all know, number of moles is equal to given mass by molar mass. So the given mass is 69 of Fe, 69.9, and the molar mass is 56. So it comes out to be, that is 1.25. So I'll place this one here, that is 1.25. Again, when we find the number of moles of oxygen, we see that is the mass given is 30.15 divided by the molar mass of oxygen, that is 16. So the answer is, that is 1.88. When we divide, we get 1.88. So I'll write this one. So now to find out the simplest ratio of moles of the atom, now we have to see the smallest number, that is 1.25 and 1.88. The smallest number is 1.25. So we will divide this to get the empirical formula. We will divide 1.25 by 1.25, as this is the smallest number. So again 1.88 divided by 1.25. So it comes out to be 1 and it comes out to be 1.5. So now we got Fe is equal to, that is Fe is 1 and O is 1.5. So Fe, I can write Fe 1 and O 1.5. So this is not a whole number. To get a whole number, we have to multiply by 2. That is Fe twice O 3. So the empirical formula is Fe2O3. So students, next Our topic is stoichiometry and stoichiometry calculation. What is stoichiometry? This word has been derived from a Greek word, and this is known as, that is, element. In Greek it is element, and this is measure. Metron, that is, metron is measure. So this is calculation based on the quantitative relationship between reactant and product are referred as stoichiometry. So what is, once again I will say, what is stoichiometry? Calculation based on quantitative relationship between the reactant and the product is regarded as stoichiometry. In order to solve the problem based on the chemical calculation, following steps are quite helpful. First, we have to write the first point is write the balanced chemical equation. Second point, that is, second, from this chemical equation, write the molar ratio between the given and required substance. Write the molar ratio between the given and required substance. Third point is convert this mole into desired parameters such as mass or volume. So desired parameter such as mass and volume. So moles is interchangeable to number of molecules, and here again it is interchangeable to mass. So students, as I told that the moles is interchangeable, that is, we can convert it into number of moles or we can convert it into number of mass. So let us see an example, that is CH4, that is methane gas. When it burns with oxygen, it gives carbon dioxide and water. So here we can see from this reaction, that is 1 mole of methane reacts with 2 moles of oxygen to give 1 mole of carbon dioxide and 2 moles of, that is, water. Similarly, if in respect of molecule, I can write 1 molecules or 1 molecule of methane react with 2 molecules of O2 to give 1 molecule of CO2 and 2 molecules of water. So this is in respect of moles, this is in respect of molecule, and next, that is in respect of volume. So volume, that is 1 mole of gas, 22.4 liter of suppose that is methane. So 22.4 liter, that is 1 mole of gas, and 2 moles of gas, that double, that is 44.8 liter, and here again 1 mole, so I can write 22.4 liter, and here then again that is 2 moles, that is 44.8 liter. So this is in respect of volume. So, or again this is in respect of volume. So in respect of mass, 16 grams of methane and 2 into, that is 32 grams of oxygen and 44 grams of CO2 and 2 into 18, that is 36 grams of H2O will be involved. So the last point that we have to know is then calculate the final result by applying unitary method. So students, let us see first this question based on the stoichiometric calculation. How many grams of oxygen is required to completely react with 0.200 grams of H2 to yield water H2O? Also calculate the amount of water. At first we have to write the balance chemical equation. So balance, that is hydrogen plus oxygen gives H2O. So let me first balance this one. So O, that is 2, so twice of this. So here 4 hydrogen, so we write twice of H2. So this is a gas, again this is a gas, and this is also in gas. So first of all, let me write in moles. According to the question, we will write in moles, that is 2 mole, here 1 mole, and here again 2 mole. So in respect of grams, we can see that is 4 grams. Here we have 16 plus 16, that is 32 grams. And here we have 18 into 2, that is 36 grams. So first of all, it has been asked that how many grams of oxygen is required to completely react with this amount. 4 grams of H2 require oxygen. 4 grams of H2 requires oxygen is equal to 32 grams. So according to the question, so 0.200 grams of H2 requires oxygen is equal to 32 by 4 into 200 grams, which is equal to, that is 4 8s are 8 to the 16, that is 1.6 grams. Am I clear? So next, again the second part is been asked, that is the amount of water. So now again 4 grams of H2 produce H2O is equal to 36 grams. So I can write 4 grams of H2 produce is equal to 36 grams. So 0.200 grams of H2 produce is equal to 36 by 4 into 0.200. So it comes out to be 1.8 grams. Understood, student? Limiting reagent and limiting reactant. Students, we are quite familiar with the cooking gas LPG. It is mainly butane and propane in liquefied form. The gas comes out from the nozzle and burns in oxygen present in air. When the cylinder becomes empty, the gas doesn't burn even though the oxygen is still available in excess. Propane and butane no longer available, so they may be regarded as limiting reactant. So consider the combustion of hydrogen, in which you can see twice of H2 reacts with O2 to give twice of H2O. So required is 2 mole, 1 mole for the formation of twice of H2O. So now suppose you have been given 2 moles of H2 and 2 moles of O2 for the reaction. So according to the equation, 1 mole of O2 is required for the complete combustion of 2 moles of H2. So 1 mole of O2 will be left over the completion of the reaction. See here, 2 moles is given and 2 moles. So as I told, that is 1 mole of O2 is required for the completion of combustion of 2 moles of H2. So 1 mole of O2. So 1 mole of O2 will be left over the combustion of the reaction. So we can say that the amount of product obtained is determined by the amount of reactant that is completely consumed in a reaction. Here H2 is consumed, so the reactant is called limiting reagent or reactant. So once again I am saying the amount of product obtained is determined by the amount of reactant that is completely consumed in the reaction. Here H2 is completely consumed, the reactant is called limiting reactant or a reagent. Let us solve a question based on this. So students, let us see a question from your exercise, NCERT exercise question number 23. A nitrogen and hydrogen reacts to form ammonia. According to the reaction, that is nitrogen plus hydrogen gives ammonia. If 1000 grams of H2 reacts with 2000 grams of N2, will any of the two reactant remain unreacted? If yes, which and what would be its mass? Second part, calculate the mass of NH3 which is formed. So for solving this, first we have to write the equation, that is balance equation. So the equation is N2 gas plus thrice of H2 gas gives twice of NH3 gas. Okay, now we know here the mass is 28 gram. For here the other mass is, that is 3 into 2, which is 6 grams, and here for ammonia it will be 2 into 17, that is 34 grams. Is it clear? So now according to the question, 28 grams, we know the 28 grams of N2 requires H2 is equal to 6 grams. See, so according to the question, 28 grams of N2 requires 6 grams. So we can write here as 28 gram of N2 requires H2 is equal to 6 grams. So 2000 grams of N2 requires H2 is equal to 6 by 28 into 2000. After solving this, it comes to be 428.6. So the first part, that is over here, we can see that H2 actually available is 1000 grams. Okay, now this means that H2 is in excess and it will remain unreacted. So which one will be unreacted? That is H2 is unreacted, because here as it is supplied 1000 gram, we required only 428.6 grams. Okay, so the next part, so the mass of unreacted H2 is equal to, that is 1000 minus 428.6, which comes out 571.4 grams. Am I clear? So our first part is over. Now the second part, that is mass of NH3 formed. So our second part is mass of NH3 formed. So from the equation, we know that 6 grams of H2 will form NH3 is equal to 34 grams. So I can write 6 grams of H2 will form NH3 is equal to 34 grams. So 428.6 grams of H2 will form NH3 is equal to 334 divided by 6 into 428.6. After solving this, which comes to be 2428.8. Am I clear? So this is the answer. The last part, that is calculate the mass of NH3 which is formed. So students, from limiting reagent, there is a question for home assignment. You have to practice it. The question is from the exercise NCERT exercise 24. Identify the limiting reagent if any of the following reaction, that is A plus B2 gives AB2. First question is 300 atoms of A plus 200 molecules of B2. Second is 100 atoms of A and 100 molecules of B2. 5 moles of A and 2.5 moles of B2. 2.5 moles of A, 5 moles of B2, 2 moles of A, 3 moles of B2. So I hope you can able to do this in your home. So students, I hope you have learned what I taught today. So keep practicing home until we meet in our next class. Thank you very much.